Okay, welcome back to example number 6 in section 7.8 improper integral. If we look at this integral, the first thing we will notice that this is really an improper integral because of the infinity here. But this is not the whole story, because remember we need to check where this function is not defined. So let's first of all, we know this is improper, okay, because of the infinity, but this function where it is not defined, this function, this is not defined if the denominator is equal to 0, which means x equal to 0 or this whole square root is 0, and that is the same as x squared minus 4 is 0, so x is negative 2 and 2. Now we need to check which one of these 0, negative 2 and 2 is between 2 and infinity. The only number that we need to choose is 2, and I'm going to choose 2. So here, this integral is improper integral of which type? Of two types, type 1 and type 2. What do we mean by type 1? It is, we have infinity, which is infinite interval, and also we have the unbounded function. So we have two types for this integral to be improper. We have infinite interval and we have the unbounded function. If you remember, if we have any improper integral with more than one problem, then we need to separate it up. So what we are going to do is this one, from 2 to infinity, x square root of x squared minus 4 dx equal to, okay, and we need to separate this one. Now because we have two problems, we need to separate them. So what we will do is we start from 2 to somewhere plus infinity dx. Okay, now we have to choose a point between 2 and infinity where we don't have any problem. You can choose a 3, for example, and so on. Any number would work for you. Okay, now if you look at the first integral, this has only one problem at 2. If you look at this integral, we have only one problem at infinity. We need to solve each one separately and we add the answers. Now I'll just leave it for you as an exercise to try it at home. I can give you the hint. Here is the hint. I will just write it down. Okay, here is the hint. I guess I'll just write it down here. Use the substitution x equal to secant theta. Okay, if you can read this one, that's the hint that you would need to use in order to solve this question. Okay, it would be very easy, very simple, because you have something square minus a number. Okay.